The idea of creating laws for corporate AI isn't some far off futuristic problem. It's a challenge we're facing right now. And a really fascinating new paper proposes a surprisingly elegant solution for how humans and these autonomous systems can actually coexist, even in the boardroom. Let's dive in. So just imagine this for a second, an algorithm that gets a vote on your company's future. I know, it sounds like something straight out of science fiction, but it's already starting to happen. Now, we're not talking about some kind of all-knowing superintelligence, but a very sophisticated system built to analyze massive amounts of data and make strategic decisions. And this right here brings up a huge question. How in the world do you write laws for a mind that thinks in code, not in concepts? To even begin to tackle this, we have to understand the core problem. And it's really a clash between two fundamentally different ways of seeing the world: human law versus machine logic. And this slide, well, it just lays out the problem perfectly. On one side, you've got human law. It's built on these wonderfully ambiguous but powerful words like reasonable or fair. But on the other side, you've got machine logic. And to an algorithm, all that flexibility isn't a feature, it's a bug. An AI needs mathematically precise, literal instructions to work. There's just zero room for interpretation. And this isn't some new idea that just popped out of Silicon Valley. The dream of a computational law, a system that could solve disputes with the certainty of a math problem, that's been around for centuries. The big difference now? The technology is finally catching up to the dream, which means we have to get serious about the practicalities. So how do we bridge this massive gap? Well, the paper points to a fantastic analogy from a field that is already wrestling with this exact problem: autonomous vehicles. The key concept here is something called the Operational Design Domain, or ODD for short. The easiest way to think about it is like a safety bubble. It's a crystal clear set of rules that tells the AI exactly when and where it's allowed to operate. It's not about trying to teach a car to handle every single crazy thing that could happen on the road. Instead, it's about defining the specific situations it was built to handle safely. For instance, a car's ODD might say it can only drive itself on highways, during the daytime, in good weather, and within a very specific city limit. The moment you go outside those precise conditions, a human has to take over. This brutally simple idea of creating a dedicated, safe space for the AI to operate, that's the key. And this brings us right to the paper's core solution. If we can create a dedicated operational space for a car on the road, why can't we do the exact same thing for an AI in the boardroom? So here's the crucial insight. Instead of trying to force an AI to understand our vague, fuzzy human laws, we create a parallel set of rules just for the AI. A dedicated computational operational context that basically translates our broad principles into the strict mathematical language that a machine can actually understand and execute. And get this, it turns out we already have a pretty good model for this in other areas. Think about bilingual contracts in international business. When a company in the US makes a deal with a company in China, they often create a single agreement that has two parallel texts, one in English for the American legal system and one in Chinese for the Chinese legal system. It's one deal, but it's expressed in two languages for two different operational contexts. And that brings us to the big aha moment of this whole idea. We apply that exact same logic to running a company. We'd have one set of bylaws for the human directors, written in natural language, full of all those broad principles and ethical standards, and then, running in parallel, a second set just for the AI, written as explicit, computational rules with measurable parameters. It's a bilingual rulebook for a hybrid boardroom. Now sure, defining these parameters without creating loopholes is a huge challenge, but it gives us a concrete place to start. Like the computer scientist Stephen Wolfram says, we're moving into an era where our agreements aren't just static pieces of paper anymore. They're becoming active algorithms. So this isn't just some abstract theory. It's the direction that both our legal and our technical worlds are already headed. Okay, that all sounds great in theory, but what does this bilingual system actually look like in practice? Let's take a really common corporate idea and see how it gets translated from human to machine. So let's take a principle like fair treatment of shareholders. For a human director, that's all about using your judgment, your ethics. But for the AI, as this table shows, it's just a checklist of concrete, verifiable tasks. The AI is literally instructed to run specific bias tests, to verify user consent through a very defined digital process, and to use a pre-approved algorithm for spreading around risk.
The vague idea of fairness gets translated into actions the AI can actually perform and that we can check.
What's really cool is that this approach unlocks totally new capabilities. Human directors, they look up performance reports periodically, maybe once a quarter. But an AI with a clear set of rules can perform continuous, real-time monitoring of everything from financial data to compliance checks. Oversight goes from being a periodic snapshot to a constant live feed. But, and this is key, that only works if its operational context very precisely defines what data it's supposed to look at and what metrics matter. Okay, so let's zoom out for a minute, because this idea of creating company-specific rulebooks for AI, well, it has much, much bigger implications for how we might build the entire legal system of the future. Think about it. By letting individual companies develop and test these bilingual governance models, we're basically creating thousands of little legal laboratories. By seeing what works and what completely fails inside a single company, regulators can get real-world data on how to draft laws for everyone else. It helps us avoid the huge trap of writing laws in a vacuum for technology that we don't fully understand yet. And this brings us to the paper's final, and I think most powerful analogy. Trying to make an advanced AI operate inside our messy, nuanced human legal system, it's like trying to run a high-speed bullet train on a public street with cars and bikes. It is just not the right infrastructure for the job. You see, powerful technologies like trains and airplanes achieve incredible speed and safety precisely because they operate on dedicated infrastructure, their own exclusive tracks and air corridors. The argument is that advanced AI needs the exact same thing. And the data totally backs us up. Just look at this chart showing fatality risk. The difference is staggering. Rail and air travel, which use that dedicated infrastructure, are just orders of magnitude safer than cars driving around on shared public roads. The point is crystal clear. Dedicated systems create safer outcomes. So a dedicated legal framework for AI isn't just a good idea, it's a safety feature. So this all leads us to one massive final question. We're not just talking about corporate bylaws anymore, are we? What we're really truly discussing is the first step toward writing a constitution for artificial intelligence, a foundational set of rules that defines its rights, its limits, and its relationship with all of us. The question is no longer if we're going to need one, but how we even begin to write it.